In this topic, we're going to discuss fetal hemoglobin and the myoglobin oxygen dissociation curves. Now, before you watch this video, make sure that you are familiar with the oxygen dissociation curves that I discussed in the last topic. So it was entitled The Transport of Oxygen. So in this topic, we're going to discuss the gaseous exchange in the fetus, fetal hemoglobin dissociation curves, myoglobin, and the myoglobin dissociation curve. Now remember that gaseous exchange occurs in the placenta, and the fetus's blood is not in direct contact with the maternal blood. Instead, it flows very closely past the mother's blood in its own capillaries in the placenta. So how does the fetal blood pick up oxygen from the mother's blood? Well, the fetal hemoglobin has a higher affinity for oxygen compared to the mother's hemoglobin. So let's have a look at the graph. So as I mentioned, fetal hemoglobin has a higher affinity for oxygen compared to the mother's hemoglobin. So the oxygen dissociation curve is to the left of the maternal curve. The fetal hemoglobin will take up oxygen from the maternal blood. So why does the fetal hemoglobin need to have a higher affinity for oxygen? Well, the partial pressure of the fetus's blood is less than or equal to the mother's blood. So if they had the same affinity, the fetus's blood would not take up much oxygen. So let's look at an example. If you look at the partial pressure about 35 millimeters Hg, what is the saturation of hemoglobin in the mother? Well, it's just above 60%. What about in the fetus at the same partial pressure? It's about 80%, showing that the fetus has a higher affinity for oxygen, or the fetal hemoglobin. Okay, looking at myoglobin. Myoglobin is the red pigment in muscles. So here you can see it's that little guy clinging onto oxygen. So its main role is to store oxygen. It's made up of a single polypeptide, and it forms a stable compound. So it's only a single polypeptide with one heme group, so it can only take up one molecule of oxygen. So it's used to provide an emergency store of oxygen at times when the rate at which muscles are using oxygen exceeds the rate of supply by the blood. If we look at the oxygen dissociation curve, myoglobin has a higher affinity for oxygen compared to hemoglobin. So its oxygen dissociation curve is to the left. So how to remember this is if you have a tighter bond with someone and love them, then the curve is to the left. This ensures that the oxygen for the muscle action is taken from hemoglobin rather than myoglobin. So myoglobin will only be used when the hemoglobin supply has been used up. So it also ensures that myoglobin is rapidly reloaded with oxygen after exercise has ended. So let's analyze this curve. At what partial pressure of oxygen is the myoglobin and hemoglobin 50% saturated? So myoglobin is much lower than hemoglobin. This means that for myoglobin to give up its oxygen, the partial pressure of oxygen must be very low, much lower than hemoglobin. Can you also see that myoglobin reaches 95% saturation at a lower partial pressure compared to hemoglobin, showing that myoglobin has a higher affinity for oxygen. The muscles of diving animals such as whales and seals contain a lot of myoglobin, so this acts as a store of oxygen to sustain them for long periods underwater. Right, in summary, if you were to draw the oxygen dissociation curves for myoglobin, fetal hemoglobin, and normal hemoglobin, the myoglobin would be furthest to the left, the fetal hemoglobin would be in the middle, and the normal hemoglobin would be on the right of both of these. This means that myoglobin has the highest affinity for oxygen and only dissociates from the oxygen at very low partial pressures. It also associates with oxygen at lower partial pressures compared to the fetal and normal hemoglobin. What about fetal hemoglobin? Well, fetal hemoglobin has a high affinity for oxygen compared to the maternal hemoglobin. So when the fetal hemoglobin flows past the maternal blood in separate blood vessels in the placenta, the fetal hemoglobin will readily pick up the oxygen from the maternal hemoglobin. And that concludes our lesson. The end.